Hello, this is Clayton Balmas, and I'm very pleased to share with you today that the future has arrived, where bio-based, high-performance, and bio-enhanced technology can be used not only for surface preparation, but also with green technology that can be used in the clutch bonding world, all right, to enhance the adhesiveness of what happens. Now, Clayton, is there really a problem out there? Well, yeah, there is. Here we've got three types of disc material. We have carbon, Kevlar, and the paper. Now, you've seen these before, everybody that's in the industry. We got Borg Warner, Tri-Component, Raybestos, etc. But the issue that we run into, that's the problem, isn't the paper material. It's usually the adhesion that takes place. And in the adhesion that takes place is the butyl rubber that's on here, normally from Heinkel, creates the chemistry, and then over time it evaporates, goes away, and it's not as effective anymore. So we're going to share something that will work with all of the friction materials that are on here and be very universal. Now, how do we currently do it? Well, those that are industry know that we've got to do this pretty fast. So what we do is we take a rag, we dip it in usually an MEK methyl ethyl ketone, all right, and we just wipe it around a couple times. That's what the guy's doing, and then maybe he cleans it, maybe he does, it does pretty well. Then he maybe throws a rag back in there, has some cross-contamination. Then he'll take the disc, he'll put it on, yeah, it's kind of there, but it's not sticky and tacky, right, because it was dried up. Remember about that? So usually after the 6 months, so then he'll move the disc to the next one, then all of a sudden he'll bump it. Oh no, well he ain't got time for that. So he could put it in the bond or cockeyed. All right. Also, we need to increase the phenolic resin that has been evaporated away, or the solvents that have been evaporated away into the chemistry. So as I said, I'm about to share with you something that will work with all of the disc components that we have. What is that, Clayton? That is our new two-step process. The one that we have here is called Prepsolve. Prepsolve is a non-MEK or non-acetone industrial surface cleaner. This is the direct replacement for the MEK that we used before. It does the same performance technology except it's bio-based. And step two is the phenolic resin. Remember how we talked about that phenolic resin is within the adhesive of the rubber that's on the back side of the friction disc? Well, this will help put a little bit more on there. Well, Clayton, do you actually paint it onto the disc itself? No, we can't do that. That'd be a mess. So we're going to do something a whole lot easier. First, we're going to prepare the product. Now you can see our cans that we have here are OSHA regulated with labels, and then to avoid physical contact, we have this ergonomically designed brush. So we put the brush, we put it around so we have a portion control on there, throw this back on there, which helps reduce some of the evaporation that takes place, and then we calmly go around and we clean it, and we go 1 for the money and 2 for the show, and we go around. You know how this works, right? And then you can see everything that it was able to clean up. Amazing. So it was able to clean it, and then the next thing that we do is we take the SureBond that we have here, all right, which is the phenolic resin, and now we place the phenolic resin upon the metal surface. As you can see here, it goes on very evenly, very brushed on good, right? So we had a portion control there. So why? Now, as I said, it's the very same phenolic resin technology that is within the rubber, but now it's kind of like back buttering a brick. So that now we have a sticky adhesion, okay, on the metal surface, which is the same chemistry as here. So then we place the disc on there, make sure that it's all even and straight, and we just go maybe a little bit press around, and we're about to put it in our oven that we have. And then you can see now when they go to move it, the disc ain't moving. All right, look at this, look at this, look at this. It's already on there. Hell, I could flip that thing upside down. She ain't coming off. All right. So she's doing right there. It's a great job. We just solved one of the issues of the disc coming off. It's sticky tacky. on there. We put it in the bonding oven for 5 minutes. Okay, it comes out, and this is what it looks like. Beautiful. Okay, you can see on here. What's this? This is the, you can see this is the phenolic resin that was on the metal surface. It got baked in at our 450 degrees. Well, how good is this chemistry good for, Clayton? It's good up to 650 degrees. It has it helps this bond, so you know when everything squeezes in, it's wonderful. Well, who else uses that? Well, you've seen it when the torque converters get torn down. You know, Toyota, Honda, Nissan. These are the people that use this technology, and also selected people in high performance and OEM here in the United States. So what's this do? Well, if you're in the facility and you're walking through and you want to make sure for quality control that it was bonded, all you got to do is see the golden hue and it's done. So there you go. So here we have, in general, we have a chemistry which fulfills 3 things. Number 1, it is safe for the worker. Number 2, it is safe for the environment because it is a bio-based technology. And number 3, we're putting more of the phenolic resin and the adhesive performance upon the friction disc so that it will have a better bond. All right, number 4, a better bond with better performance, repeatability, and manufacturing for you to have a better product, happier customers, longer life. So this is Clayton Balmas with Spartaclean Biotechnologies here at SpartacusGroup.net, and we want to say thank you for being with us, and we'll see you at our next video. Bye now.